bays in this, so you can run redundant power supplies. With all the bays on there though, you might add more hard drives, which is beyond the capabilities of a single PSU. That's limited by the thing. So what I've done is the ATX board power cable, if it's in the bottom one, is because it's a small board, it's so far away, so I'm swap it over to the top. That went a bit wrong. The problem with that system build was this board. It tested out the week or so before as fine. I went in there, put it in, and it was a no-go. So I thought it was the SAS card in there causing problems. It turns out there were two problems, one with the SAS memory, needed reseating, and the board itself. So I've tried this board again, and it won't boot up. It just goes in a boot loop, it powers up and powers straight back off. Because I tried the SAS card in it, maybe these two MOSFETs here, which are blown, but I haven't tested it, but that was what the problem was. So at the time, which was probably about 3 weeks ago now, what I did is I've changed over and we're going to go into a HP Synology xpenology NAS system. It's only got 5 drives in it as opposed to the 14 that we were building. So what we can do is crack on, and we'll go through quickly the HP NAS. It's a lot more affordable and quite easy to do. So we'll go through that, and we'll go through some tech spec shortly. Okay, modifying the system was relatively easy. First of all, you need to get yourself a USB drive, a little flash card, anything will do. Put the new BIOS on there, which is not a new BIOS, it effectively unlocks the BIOS that's already on there. The onboard SATA, which is located at the front, is speed restricted and protocol restricted, so you can't really use it as a normal drive, although some people have actually reported that they were able to, but they probably just didn't notice that there's a huge speed difference. So what we did is you quickly pop this in, flash the BIOS on there, which it takes a couple of seconds to do, and then you take it out, wipe your USB stick down, and then put on the xpenology bootloader. That's really simple. You put that on there, wait for it to run through. It doesn't take particularly long, although on the system reboot it does take a little while to get started. Once it has started, it will direct you to Find My Synology, where you can upload your software to it. That's really nice and simple and straightforward. After you've booted it up, found it and everything else like that, it takes a minute maybe to load up after it's switched on, and you have the full web interface as you would expect. You also have direct access once you've put in your pulls and everything else. Now I changed over my modification so that the optical bay is a hot swap caddiless,
bay, giving me 5 hard drive spaces. So on there we have 2 2TB and 3 500s. The 500s are in a strip, give me 998 gigs. That was just a performance test. I don't recommend using it. Obviously, as you saw in the real world performance, the transfer speed over a 1 gig network is about 108 megs. So even like older drives, SATA 2 drives, will be perfectly fine for this application. There's no need to go out and buy SATA 3s, although you may want to do that if you want to upgrade to something a little bit bigger, like what I was showing at the start of this video. Now, I have enterprise level storage servers, and I have a HP Microserver, which is supposed to be an enterprise class server. You have to think technically about the what use cases, your data transfers, and the size of your data transfers before picking your server, because it may sound rubbish these days, and if you are in the wrong mindset, you might think that you need the bestest, fastest graphics card and processor in there. That's not the case, although this isn't a Plex server or video transcoder where video editing or video transcoding is really important. It's just simply a file server, backup file server with Windows opportunities on there. But don't forget though, if you really wanted to make something really simple, you could literally get an old XP system, install XP on it, and then open up a drive for a file share over your network and restrict your security with a firewall and access in and out of that XP system. So I hope you like this video. I'm just going to go now into the technical information in respect of how to spec out data flow, RAM, etc. and system performance over your network speed. So your network speed, your hard drive speed, and the system speed for that NAS, and what that actually would need to be. We go in quickly into that, and whether you need the 2 gig network. But obviously on this one, I've not upgraded the network. I could put a 10 gig in there, but I don't think it's worthwhile, because there is there'll be a slowdown, especially with the SATA performance on that. It won't fit any of my SAS cards in there. They're all server enterprise level and slightly too big to fit in there. There is enough space in there for a single graphics card or single network card, a single depth network card, but the airflow isn't what I would call great. The hard drive temperatures in there are a little bit higher than what I would normally like. They are at 40 plus degrees, whereas I prefer them to be about 25 and maxing out at kind of around a 30 mark, which is a lot better for them. So yeah, so I hope you like the video. We're going to go into the technical stuff now, so if you get bored of the technical stuff, you probably want to just skip out. If you like the video, click a like. If you want to subscribe, make sure that you actually subscribe to the computer and network playlist rather than the whole other topics which I cover as well.
And so today we're doing a quick summary of storage networks. This is going to be quite the technical view of it, just so you're making the right choices in how you should or how you can make your network storage work for you. So let's go to pen and paper, or pencil and paper, just to go over some technical things first. This is a consideration for what you're buying, how much it's going to actually cost you, and what sort of performance you're going to get. So let's go to the paper. So what we're going to look at first is your hard drive storage. So let's put that there. This is your normal data, I'll call that ND. This is your storage data, and then over here, this is important, is your archive data. Now on your computer, you're going to have your hard drives installed, but you'll want to back up to your storage data. So the speed and this speed
have to be equal. This speed here has to support it. So let me give you an example. If this writes at 80 megabyte and this writes at 80 megabyte, then this speed here needs to be probably about 82 megabyte. Because there's a network overhead of transferring data backwards and forwards, so you're going to get a bit of an overhead. So let's look at 1 gigabyte a second, or 108 megabytes a second. This is your internet transport speed. This will be your data, so net and data. So if I had a 1 gig network card, I could write 108 megabits across it. So I would have at least 120 megabytes a second drive, and that's been quite easy to get in the last decade. Prior to that, you'll probably be looking more to 80 megs on a drive. You'll have to speed test your drives to find out exactly how much speed they will actually perform as their peak, although smaller files tend to run a lot slower. So this archive obviously is important, because not only will you store data on here, you might have live data. So for example, if you have a computer, a 250 gig hard drive in there, which probably has a 1 terabyte software drive on there, then you might want to go, well, actually what I want to do is I'm going to get all of that software off here and put it on storage, and then I'm just going to transfer that there. And because I've got that, I also want to be able to back up, and then I want to be able to share. So it becomes really important then, because if you're backing up, normally if you're using the computer you wouldn't be normally doing this, but you might run a backup whilst playing games on your computer or working or something like that. So this speed here increases. So if you want to be able to do 2 things at once, well then you're going to need 2 gigs or more. And then if you've got a shared drive, and this is put to, hang on, I'm going to get a little bit confusing here, a hub, then your hub or network switch has to be able to contend with both connections. So for example, you might have this plugged into a hub, so your computer goes to a hub which then goes out to network storage, and so your speed there will be on how many on your connection plus bandwidth. So that will dictate then how quick your hub is and your network, and then it becomes down to, does the device have the bandwidth? Yeah, that makes absolute perfect sense to you. So if this was all 1 unit and 1 LAN card coming out, then we start to get problems as soon as we have 2 users on there, or we're doing 2 bits of work. So it becomes a system bottleneck. So what we want to try and do is avoid this. So our backups and our archives are always on a separate machine, which is switched off, because switching it off and disconnected is safer than having something that's powered on. And this becomes down to your fault tolerance. So no matter how you back up C, D and F, if this is your drive in your workstation, they're all connected to the same power, board, controller, internet. There we go. So there's your 4 points of failure. Now your power supply might break, your board might break, the controller might break, or your network might break, or you'll get surges, and all of these are all connected together through all of these, so therefore you can lose everything in 4 different ways at least. We didn't include viruses or errors, and by errors I mean like people accidentally deleting folders and stuff like that. So there's a good few ways of losing data. If we use a sync back and we're syncing viruses, then that's obviously this, or even the errors on there. And in fact, on some occasions I've noticed a network fault, so you can get a network corrupted data flowing across, which will ruin any sort of space that you've got. It can happen anyway on your local system. A small break in the cable and such can do it. So what we need to do then is to come across from this and do this. So this is your 3-2-1 situation. So you might back up to here, which then backs up to here, and then a secondary backup to here. And these are your storage devices that are separate. So if we have, this is a net arc, as in an archive, and this is net live, then you can use this as your hard drive. So you have a hard drive array here, and then this can be connected, in fact, this way, between that and that. So you're just copying this to this. This takes your load off your network and off your workstations, or you can literally copy them over. Now my preference is, because I have live copies and I know the copies are good on my system, that I would copy it directly to the archive, and then there's some fault tolerance from the net drive if there's any faults on this network drive. So there we go, that's the basics of how you would do it, on system, off network, off network, and off backup, and off system. So going back to this, if we have a 1 gig network, 108, you're at lower speeds, so performance matters. So I might have 155 megabytes second per drive, which is over 1 gig obviously. So I might set that into a R0, we'll call that 300 megabytes a second. Now if I'm on an SSD, I should be able to get 375 megs per second. So if I'm doing 375 megs a second, let me just do the maths on here. So if we looked at 375 megabits per second, so as you can see, if I had a 3 gig network connection, I can run quite easily this RAID set here with some overhead. But what we need to do is that SATA 2 at full speed. So if we had SATA 3 is supposed to be 6 gigabits, and that one's 3 gigabits a second. So as you can see, the difference here and the performance, I could technically get, this is 2 drives, so that 2 times will equal 300, or I could do 4 times equals 600. Then it comes down to the RAID set. If you have, so if you had a RAID set that has together, so if you had a RAID set of drives, they all work as one. So this would be one drive seen there, but 3 times the speed. If one drive fails, you lose all the data across all 3. So it's not a practical solution as such. So what you would have is another 3 drive here, and this would be R01. We call them R01s, but it's usually an R10. Is quite a normal one. So basically what you're doing is you're copying the data that comes in to both of those. So if one drive fails here, this array goes off, but you still have that. So that gives you a level of redundancy, but you need twice the space or twice the drives to be able to make it. So that comes down to your storage. Can you have 6 drives to equal 2 drives, and will it fit in the storage? So you're looking at, for this, is nominal performance. Nominal performance drives. There's 6 in this drive set, which will give you 3. If they're 4 terabytes each, you're going to get 4, 8, 12 terabytes. 12 terabytes of storage on this. Or you could have 6 or 14 terabytes. It's up to you how much you have on there. But obviously then it's on your archive. If that was 12 terabytes, then your archive would need to be 12 terabytes as well, exactly the same, so that you can actually copy over your array here to your backup, offline backup, as we say. So if that makes things rather clear as to how you should set them up for your performance and what sort of performance you'll get, this is going to be, the big issue here is, how do I get a 3 gig internet connection when my network is only a 1? So there's a few options here. It is either a 2.5 gig, they do a 2.5 gig network card if you can get hold of them. They're quite rare actually, they're not that simple. Or you just jump straight up to a 10 gig, which are a lot more easier to get hold of. So if you had a 10 gig, that's 2.5 user. So that's going to be absolutely perfectly fine. Now you probably want to go down on a budget. So what we'll do then is we'll go back up now. We finished on the paperwork. You see me scribble loads of notes. You probably have to watch that about 3 times to try and make sense of it. So as long as you know that your drive speed in megabytes, 375 megabytes, is going to be 3 gigabytes of internet speed to be able to write 375 megabytes, which is just under the speed of an SSD, or 1 SSD for a cache. Yeah, so that should make some sense to you. Right, and then obviously we've got RAID strips and mirror RAID over on here, so it writes twice, which can slow down the system, which then goes to the storage, as well as drive performance to storage bays. How many bays can you have in that storage? This is to stop you having problems, but you obviously need more users, more bandwidth, and more data flow. But we'll go into data flow a little bit more in detail later.